Hello and welcome to SUSECON. Welcome to tutorial 1238. Today we would like to talk to you about SUSE Manager High Availability Disaster Recovery using Postgres Streaming Replication. Just to give you a brief overview about the next 30 to 40 minutes, we would like to share with you some general consideration about high availability when it comes to SUSE Manager. We would like to talk to you about important configurations, how to achieve that, how to monitor the replication, and then at the end, we would like to show you what happens if we fail over. My name is Jörg Bunse. I'm a sales engineer at SUSE.
And my name is Bo Jin, sales engineer at SUSE as well.
Hey Bo, every once in a while, customer asks me about high availability with SUSE Manager. If I think of the efforts how to achieve high availability, my first guess is always a good backup strategy might be better than high availability. But I've heard that lately you implemented a simple but very effective high availability at a customer. Can you tell me something more about it?
Yeah, Jörg, thank you. Thank you for these words. And that is the whole idea of this session, that we would like to introduce this concept of SUSE Manager High Availability. So first of all, let's have an overview look at what are the objectives we would like to achieve, or in other words, what were the requirements we had for a large customer of mine when I implemented the SUSE Manager. So the SUSE Manager high availability or disaster recovery concept requirement were to be able to recover to another SUSE Manager host that is already up and running, but with a static but different IP address. Let's call it the standby SUSE Manager or the backup SUSE Manager, which is always running. We call it secondary SUSE Manager. Is running in a hot standby mode or warm standby mode. Yeah. So what that exactly is, I would show you in the next steps. And of course, customer had the requirement to not use any additional tools, either from beginning from pacemaker to DRBD or even any other third-party tools, because most of the administrators don't like to use too many different tools because they need to manage these tools as well. So that was another key requirement. And of course, failing over to another host should not make the needs for configuring other existing SUSE Manager proxy server and salt minions. So these existing minions and proxy server should be untouched. They shouldn't need any reconfiguration, and then they should be able to talk to the secondary SUSE Manager after failover. And the concept should also allow long distances. So what does it mean? So we know from high availability concepts that synchronous mode needs a very short distance over the for the two systems in order to not have big latencies. But this concept would allow even some long distances. So like in my case, in my project case, the two SUSE Manager servers are located in two different data centers, and they are about 300 kilometers away from each other. So we do have some little latency. But that is, as I said, we will talk about it. The sync replication of the database in special is running in asynchronous mode. And the recovery time should be fast or very quick. We are talking about almost zero downtime, but that means there is a short downtime, approximately 5 minutes, because we need to do some manual steps, the DNS reconfiguration, for example. So in total is, I would say 5 minutes is very realistic. And that is also what we so far have been tested at our customer site.
Okay, so Bo, we're not talking about the most desirable 99.999% uptime. We're talking about 99.99.
Yes, I would say that is very pragmatic, because most of the customer of using SUSE Manager don't need SUSE Manager to be running like a SAP HANA database, right? So we can have a short downtime of couple of minutes, and I think that if that is affordable, then I think any customer using SUSE Manager can use this concept as well.
Okay, so the worst thing that might happen is you are not able to patch a system for maybe 15 minutes.
Yeah. So of course, 15 minutes is maybe for somebody already long, but I would say 5 to 10 minutes is very realistic to get the standby SUSE Manager up and running.
Okay, got it.
Yeah. So when we look at this concept, let's start from the 1,000-meter point of view. So we have a two-level replication on the one hand side. On the left side, you see the nice Postgres graphic. As everybody of SUSE Manager user knows, we use in-place Postgres database that is located on the SUSE Manager host itself, and the Postgres database system itself has a very well-developed replication mechanism. So that is one we use built-in mechanism to replicate the data from our current running primary SUSE Manager to the standby or secondary SUSE Manager server. And then we use bash script that will be triggered through cron jobs to replicate the important files from the primary SUSE Manager to the secondary SUSE Manager server. As you can see here in the screenshot on the left, on the right side, in the bash script, we defined the important directories, and those content will be synchronized by using rsync from primary server to the secondary server.
Mm-hmm.
So far clear?
Yep.
Okay.
Works for me.
Yeah. So let's talk a bit about what exactly is that replication mechanism in Postgres database. So to be very precise, we are using a log shipping based replication. It's called in Postgres language physical streaming replication with replication slot in asynchronous mode. Okay, so they to be highlighted words are streaming replication plus replication slot. Okay.
Well, slot seems to be pretty important. It's printed in red. Why is that?
Yeah.
And what is that?
Yeah. So why is that, and why we use slot additionally? So as we can see in this picture, on the left-hand side, we have the primary Postgres database, and the WAL, WAL stands for write ahead logs. So all these logs will be written normally to the disk in a certain fixed size, and this will be then later from the database system written to the disk, into the data files. And those WAL log files will be additionally, if we enable the streaming replication, also goes to the standby Postgres database. So it will be replicated. It will be sent every single write-ahead log segment will be sent to the standby server and will be also replicated into the database of the standby Postgres. And the slot means that if the standby server is not accessible or is currently just down because of server is broken, network is down, then the primary server will keep all these val logs until this my standby server is back online and has received all the lag var logs and replicated and replayed into the database. So in other words, it's a higher security level to make sure that all the uh, data transactions we have made during the time when the standby server is not available will be sent to the standby server once it comes online again. Was that clear for you?
Yeah, understood. Okay. Yeah, so this is for the database. But what about the files? We're talking about a large number of files, not only configuration files, but the content of the repositories itself.
Yes, exactly. So as we know, the SUSE Manager is synchronizing and downloading the content from SUSE Customer Center, and also if you manage other Red Hat Ubuntu systems, it will be downloaded through internet in a nightly job. And those RPMs will be stored on local disk in /var/spacewalk. And additionally, all the other caching files, salt minion key files, configuration files, or our cobbler files, AutoYAST files, and also our custom salt configurations will be also synchronized or replicated through a bash script using rsync mainly to the remote side. So left side is the primary SUSE Manager server, and right side is the secondary SUSE Manager. And the bash script will simply triggered by a cron job every 6 hour, 12 hour, as you wish, and to replicate those data from A to B, just to make sure that we also have the files on the standby SUSE Manager server, which is quite simple concept.
Yeah. Okay, good.
Yeah, so I welcome everybody to use that to read the details. I have documented everything and uploaded to the GitHub repository. The links are here listed. And for each part of the replication, I also wrote a README in details about how to configure it and how to use it. Okay, so as you know, you have been using it. You test it as well, right? So I think that should work for everybody else.
Yes.
Yeah. So, but before you test it, you start to use it. I thought some preparation steps are quite important. So I listed here some of the steps just so that we can talk about it and to make people aware of that preparation requirements. So first of all, primary SUSE Manager must be already set up and running, right? That is, I think, very common, and especially also most of the people today these days are using custom signed TLS certificates. That is very nice, and the standby SUSE Manager server should also be set up, right? So it is first installed, and then second you run through the YAST SUSE Manager underlying setup wizard to kick on the SUSE Manager as for the initial setup. For people who already have SUSE Manager in using sometimes, that is fully okay. What you just need is to install a new SUSE Manager server on in your second data center on another on another node, and bring up this standby SUSE Manager, run through the SUSE Manager setup, and then you are quite prepared to continue and configure the replication. One thing I would like to highlight is SUSE Manager server. Both server systems should be in the same version, same major version, but also in the same minor version, right? So in my bash script, I would verify and check if both sides have the version 4.2. And later in the rsync steps, I will also even compare if the minor versions are also the same, because as we know, SUSE Manager releases quite a lot updates, and those updates brings also database schema updates. So I would like to make sure to avoid any failure and mistakes. So before I change and copy everything over, I want to make sure that both sides have the same system. If this is not the case, the bash script would throw an error. So by default does not allow remote connectivity to the Postgres database. So in order to make change, because we need to talk from the standby SUSE Manager server to the primary SUSE server, right? So we will need to connect from standby to the primary SUSE Manager database. We need to allow connections from other addresses. So in the Postgres SQL.conf, we need to add the listen address with asterisk, or you can put your addresses and subnet here. And in the pg_hba.conf file, you would additionally need to allow the so-called replication user to connect from the remote standby server to the primary server. So these steps need to be done on the primary server, as the slide title is showing.
Yeah. So when talking about using a, let's say, kind of a service user, what kind of authentication is used just to ensure security?
Yes. So for the replication users, like in my case here in the middle of the page, we in order to allow the replication user to do passwordless login to the Postgres database, we create a .pg path that is read-write only for the Postgres and the root user. And inside of this file, you just simply put asterisk, column, asterisk, column, asterisk, and then the username. So the first three asterisk stands for host. Yeah. So we replaced it with asterisk, which means any host.
Mm-hmm.
Second asterisk stands for the port. So usually is the 5432. So we replace it with asterisk as well, any port. And the third is for the database. We replaced it using asterisk for any database, and then it comes to the username. In my case, it's rep, which is the name of the replication user, and column, and then the password for the user. Yeah. So with that, the user will be authenticated to the Postgres database on the primary SUSE Manager server.
Okay.
And additionally, of course, for the rsync file replication, we need also a passwordless root SSH login. For that, it would require people to generate a root user authorization key pairs and to send the public key into the authorization keys file from the primary server. Yeah, so that we can log in without password prompt from the standby to the primary SUSE Manager server. And of course, the SSHD should not allow root password login. Yeah, so it does not interfere with the password login because we just log in with authorization key. But of course, you need to allow root login, but not root password login. I hope that is clear.
Yeah, Okay, got it.
Yeah, so with that, we continue for the file replication. It will require another configuration file, which is called suma ha underline env.sh. Inside of this file, we need 3 parameters defined. Those environment variables will give the information about what is the fully qualified domain name of this primary SUSE Manager server, what is the IP address of the SUSE Manager, primary SUSE Manager, and what is the IP address of the standby SUSE Manager server. Yeah, so these 3 information will be taken by the synchronization bash script, so that we know where to make the SSH connections to. And once more, in my SUSE, in the bash script, I would also compare the minor version of the installed SUSE Manager, just because of I really want to be very carefully make sure that they both have the same version and also the same database schema. So here is a point. Yeah, so I use this command in my bash script to capture the release, the version of the pattern Suma server, and this will be compared. If both systems have the same, I will throw a message that is you did a good job, and we continue. Yeah, so this is another. I would call it security protection I built into the bash script.
Mm-hmm.
Yeah, so now hopefully after the all the configuration steps and preparation steps you did, the replication is running. And when the replication is set up, we need to monitor the replication. So what I recommend is to use some Linux commands to on the secondary or standby server. You can make this command ps aux pipe grep while receiver, because on the standby server it is a write ahead log receiver that is receiving the log segments coming from the sender from the primary server, right? So the output would be similar like the shown here in the screenshot. You will see a line that's saying while receiver is streaming, and then the number of the current log segment that is just receiving. And on the primary server, you will see that we use a similar command, ps aux pipe grep while sender, and you can get the information that the while sender is showing that, oh, okay, the user is bool rep. I'm sending to the this IP address, which is the standby server, and just sending this streaming log segment number. So here is a Linux way of how to watch what is happening at the moment.
Okay, so once we have configured the whole stuff with the replication and so on, and once we made it working, we will see an output like this. So what would happen if it doesn't work? So in case of a failure.
Yeah, if let's assume that the standby server is down or network line is cut and not working at the moment, primarily lost connection to the standby server, then if you do this command to try to find the line while receiver on the standby server, the output will be empty, or only the first line showing grep calloc auto while receiver, but there is no output about Postgres while receiver streaming. Yeah, so this means it's not receiving anything if the standby server is still working. And on the primary, so in other words, it makes much more sense to watch on the primary server how good is the replication, and then you make the same command ps aux grep while sender, and you will not see the first line anymore if it is not able to send the log segment to the standby server.
Okay, good. Thanks.
Yeah. And the same applies for the SQL query. So you can also watch the replication status and replication lag values on the primary SUSE Manager by logging into the Postgres database as a Postgres user, and you can run this select statement, and you will get output if the replication is currently running. Especially the two lines, two green arrows show the values about the write LSN. LSN stands for log segment number. So which log segment is currently being written, and the right underline lag is showing how much behind is the standby from the primary server. Yeah, so here you see the values in this output. We have a very low lag value in milliseconds. That means we are almost in sync mode. Yeah, so we have a very good latency and almost no lag. Yeah, so here is really a very good. It's giving you much more information than the Linux command just watching if the process is running.
Yeah. So it seems as if everything's okay. We configured everything. The replication is working. Let's say the file synchronization is working as well. So what happens now if the primary server fails?
Oh yeah, that's a good question. So that is the next slide. Thank you for this question, Jörg, which is part of our playbook, right? Disaster recovery. So unfortunately, if one really we don't hope, but it happens in life when this primary SUSE manager goes down. We need to fail over. So here are the steps we need to do, right? So the first step is to rename the standby SUSE manager to get the same host name as the primary, if not already done. So we really need to make the host name change here at this step, right?
Well, just a quick one, because there are so many ways of changing a host name. Is there a way that has to be preferred as the preferred way how to change the host name in this case?
Well, there is no the preferred way, but
Okay.
I would say there are always two ways to do something on SLAS systems. As SUSE expert, might a lot of people will do YAST. Yeah, you can use YAST module to change the host name, because it's quite convenient. You just open YAST LAN module, and then you just simply put the new host name to the hostname field of the respective Ethernet interface, and then say next, and then everything is done for you. If you do it programmatically via command line or scripts, you can do hostname CTL, change with a new hostname given, and then edit the /etc/hosts file and change the entry there pointing to your IP address. Exit the shell you are currently working and log in again, because the environment variables will be reset. Then you are done, right? So there are always two ways, but I would not call it which way is the right way. Both ways are correct.
Okay, thanks.
Yeah. And then after hostname change, we have to promote the Postgres SQL from standby or from read-only mode to become read-write mode. So for doing that, we need to change user to Postgres, and then we run the command pg_ctl promote. With that, the mode of the Postgres is switched to read-write. And then, of course, we need to start the services. Here we are back as a root user and run the systemctl start Postgres. And in sequence, we run SUSE Manager start command, spacewalk -service blank start. And once the database is up and SUSE Manager is up and running, we need to ask our DNS administrator to make the change. Either you use alias, just change the entry pointing the host name to the new IP address of the standby SUSE Manager, which is now the new primary server, right? So that everybody who want to connect to the either web interface or the minions or proxy server need to reach out to the SUSE Manager via hostname will receive the new IP address of the new primary SUSE Manager. Now, this part of job is very critical and need to be done by DNS admins. And that's it. Then you have a SUSE Manager up and running again, which is running on another host. And all the minions and SUSE Manager proxy server don't need any changes. They are simply connected again. They can do zipper ref, zipper patch. They can do salt, state applies, and everything is up and running again. Isn't that cool?
Yeah. Okay. No, that looks good, and it really seems to be feasible to do the whole procedure within 5 to 10 minutes, as you promised at the very beginning of the presentation.
Yeah, so that is what in our project with this large customer, the outcome of that. So because doing all these steps is really quite easy, and it gives it's not confusing everybody. The steps are documented. The only thing is we need to have either we ask an administrator, whoever it is in your organization, to make this DNS change, or even maybe this can be automated via an API.
Okay, cool. So, so now there's one question missing.
Okay.
And what happens if the primary server comes back online again?
Ah, you mean the old primary, which was done before?
Exactly.
And thank you for this question as well.
Oh, you have a slide for it. Perfect.
Oh yeah. I'm always prepared. I can read your mind. So let's assume the old primary, which was done before, is back online, either by reboot or whatever. However, the primary server is back online, and we already switched over to the new primary server. So that means the old primary server will not receive any transactions or requests anymore, because all the minions and proxies and users will be directed to the new IP address. Of course, we should avoid another running system within the HA concept. That is one of the principles of HA. So we should stop them, right? And we can, after we fix everything, if there was a hardware failure or whatever, after we fix all the problems and the system can be reused again, we can reverse the direction of the replication. So we can reuse the old primary as a new standby server. And just by switching the replication direction and to make this server prepared for the next failover, right? So what we have to do is to, of course, we stop this current SUSE Manager service, we stop Postgres, and then we have to delete the whole data directory of the Postgres database, which is by default on SUSE Manager server in /var/lib/pgsql/data. So this directory should be deleted on the new standby. So starting from now on, we call the old primary as new standby server, okay? And one of the first step is we need to run a base backup. This is also a Postgres built-in binary that we use to run a base backup to transmit all the data from the current remote primary SUSE Manager to this standby server. Yeah, but doing this step, we run this command as Postgres user. So here first we switch with su-postgres user, and then we run the command pg_base backup -h for the host, remote host, which is our current primary SUSE Manager IP address, minus uppercase D for the data directory. So where do we hold the data files, which is by default /var/lib/pgsql/data. And then minus uppercase U for user. So we use the replication user again, right? And minus V for more verbose output, minus F for the format, P stands for the pipe, so we pipe the data simply over without using. You could use other options like T for tar files for the transmission, and the checkpoint is fast, and then the minus R for the application and slot name. So the important parameter is also minus slot equals a slot name. The slot name must not be an existing slot name. So for example, in our first failover, we might have the slot name called bow slot 1. This time we need to call it bow slot 2, okay? And minus C and minus, I don't remember anymore what is minus uppercase C. I have to look to the documentation, but minus X is for the replication mode, which is streaming. So the lowercase s stands for streaming. So with this command line, we will get the data files copied over, and the local Postgres database will be turned into read-only mode and as a standby server. And then finally, what we just need to do is to start the Postgres SQL in standby mode, and then the standby server starts to receive the replications again, right? And then, of course, do not forget to configure the cron tab job to run the synchronization scripts as well. That's it. So we just, with this 4 steps, we re-established the replication from the new primary to the new standby SUSE Manager server.
Cool.
How do you like it?
Great work. Wow. I think that's very impressive.
Yeah.
And it's well, this is a solution that's not over-engineered. It's pretty simple. Nevertheless, it seems to be very effective and robust. So
yeah,
good job. Cool.
Thank you. Thank you. Of course, those words is very lovely and not part of our playbook, right? So this is really your emotion for that.
That's true.
Thank you. So yeah, but that is of course not all. We have not reached our final destination at the moment. I would like to point out to some few topics that I will look into. So one is topic is about restore point in time recovery. Yeah. So let's say we did really some mistakes, some big mistakes in the database. We deleted some columns and so on. So even replication does not help because we replicated the failure as well. So what we can recover is by using the Postgres built-in point-in-time recovery mechanism. But for using that, we would need additional configuration with the archive command and restore command, right? So the archive command is to always constantly archiving all the var logs to an external disk space, and the restore command is to restore everything back. Yeah, so I will not go to the details because of the time constraint here. So, but if for people would like to look into that, just don't forget the Postgres has a built-in point-in-time recovery mechanism. And of course, I like to do a lot of automation. So one thing I would like to automate, as you have seen, the failover steps are at the moment manually. So we can easily automate those steps with Python script. But I have not created a Python script or Bash script yet because we just finalizing the project. We are testing, everything runs fine, and we are happy now, but we can improve that. So Python script or Bash script to automate the failover is seen as next step as improvement. And of course, I loved monitoring the replication status and send alerts if replication is not working at all. For that, I'm currently developing a binary, maybe in Rust language, or I started already in Rust, and this will constantly running on primary server, just watching the replication status. And if replication is done, as we know, it does not give the output of this select statement, then I will send an email alert, for example. So for that, I'm still the binary is still under development, and I'll keep update. I will keep my GitHub repo updates, and you can watch for that and to use that later on. I would say in 2 months from now, I will be ready with this binary. And of course, we love your feedback and the ideas and contributions. Feel free to contact us to log issues on my GitHub if you have any questions. How do you like it, Jörg?
Cool. No, this was really an impressive presentation of your solution for high availability for SUSE Manager.
Yeah, thank you.
Well, with that, I guess we came to an end.
Yeah.
Thank you very much for your attention. We hope you found it useful. Maybe you will implement this in your environment as well. We, as Bo already said, we like to receive some feedback. Yeah, and we would like to say thank you, and hopefully you will enjoy the rest of SUSECON as well and find some other inspiring presentations. Thanks a lot.
Thank you. Have a good day. Bye.
Bye.